Okay, beginning with 1-50, we have for each of the shapes formed by algebra tiles below, sketch and label the shape on your paper and write an expression that represents the perimeter. Simplify your perimeter expression as much as possible. So we're not doing area, we're only doing perimeter. So remember, for an X tile, the area of that tile is X, and the length is X, the width is 1. So each of these widths is 1. Now this is a unit tile. The area of the unit tile is 1. The length and the width are 1 and 1. I kind of jumped into that. Make sure you take the time to draw a pretty decent diagram. Pause the video if you need to. And by the way, these are in the ebook. If this is these are from lesson 1.23, and if you are using the ebook and you look at the bottom of the screen, there's a button that says Tools. If you look at my video that shows you how to use the ebook, I think I demonstrate this. This comes in really handy if you want some tiles and you're not around the classroom. So if you're using the ebook, go to lesson 1.2.3 so that you are looking at the problem, and then pause the video if you need to draw this diagram. Okay, so each of these lengths is 1. So that leaves us with this little spot right here that's not the full length of X. And a lot of people will say, well, isn't that just 2? But you probably figured out in class that if you do 2 or if you do 3 unit tiles, it does not quite equal 1 X tile. So this length from the top to the bottom is X. If you looked at the entire length of this tile, it would be X. But if you only want this part here, that means you don't want this length here. So I'm going to use X minus 1 for this length. You don't have to do it that way, but if that makes sense, this entire length is X. You don't want this piece right here, so it would be X take away 1. And I'm blanking out right now on another way to do this, but I think there is kind of another straightforward way to do it. So I'll stick with that. The perimeter of this shape would just be the sum of the lengths of all the sides. So let's see what we have. We've got X plus 3 plus X minus 1 plus 1 plus 1 plus 1 plus 3 more. So that's plus 3 plus 3, so that would be plus 6. Combine like terms, that's going to give us 2x. Let's see, we've got a positive 3, a positive 6, that's positive 9, and a negative 1, so that would be plus 8. Okay, let's look at part B. Pause the video, sketch the diagram on your paper, and then come back. So this is our y squared tile. The length and the width of y squared are y. Y for the length, y for the width. Now, this side right here isn't the full length y. It's going to be y minus 1 unit tile. So then this must be y minus 1. Because if this is a unit tile, the area is 1, so the length of that tile is 1. Okay, same thing right here. This entire length is y. This part right here, from here to here, is 1. So then from here to here is y minus 1. Okay, my XY tile has the short side is X, The longer side is y, but we don't have the full length of y, so it's just like this side over here. This is going to be y minus 1. Okay, each length of the unit tile is 1. Don't forget any of those lengths. It's kind of easy to do, especially if you draw this really, really small. It's easy to miss one of these sides. Okay, and then this entire length is x, but I don't want this piece right here. So this is just going to be x minus 1. Okay, if that was confusing, maybe you need to go back, rewind, or just go a little bit more slowly, see if that makes sense. Now I'm going to do the perimeter. I'm going to add up all the sides, so I'm just going to write it all out. This is probably going to take up a lot of room. Y plus x minus 1. Okay, let's go ahead and add these up because it's easy to add these. So 1, 2, 3, 4, 5, 6. So plus 6 plus y minus 1 plus x plus y minus 1 plus 1, 2, 3, 4, 5, 6 plus, we didn't do this one yet. This was y minus 1. We started with y. So plus y minus 1. Just made it on my paper. Okay, now let's just combine like terms. We've got how many y's? 4 y's. Just check and make sure I'm doing all this right. Okay, and then we've got 2 x's. Okay, we've got a -1, +6, -1, -1, +6, -1. So we could just add all these negative ones together if you want. So that's 1, 2, 3, 4. So -4. And then +6 and +6 is +12. So that would give me +8. So we get 4y plus 2x plus 8 for the perimeter. Okay, for 1-51, it says for each rectangle below, what is the area of each part and what is the area of the whole? So the area of each part I'm going to find by multiplying the length and the width. So pause your video, sketch these area models, and then come back to it. 7 times 11, that's 77. 7 times 8, this length is 7, the width is 8, so 56. 3 times 11 is 33. And then we have 3 times 8, 24. Then we're just going to add, so the area of each part is in our diagram, the area of the whole, we're just going to add all of these together. That's 110, 77 and 33, and then that would be 80, so it would be 190. And this is area, we don't have units, so we're just going to put units, 190 square units. Okay, length times width. 3x times 11x is 33x squared. -2 times 3x is -6x. -4, 11x is -44x. And then -4 times -2 is +8. So that's the area of each part. We do have like terms. There's only one x squared term, so let's write that one down. We have -6x and -44x. Those can be combined to give us -50x. And then +8. So remember, terms that are alike have the same variable and same exponent. So you can't combine x squared with x. These are the only two that are alike. All right, for 152, match each table on the left with its equation on the right and briefly explain why it matches the data. So I'm going to look at y equals x. If y equals x, then the y and the x term are going to be exactly the same. And there are no tables that have that. None of the tables have all of the y's and x's matching, so we can eliminate number 1. Now let's look at the rest of these. Is this linear or exponential? Hopefully you can say that that is linear. So that's a linear equation. The y-intercept is -1, the slope is 3, so it's increasing by 3. Now these tables don't increase by the same amount. If you look at the x values, this is increasing by 1 and then it goes, or sorry, decreasing by 1 and then it's decreasing by 4 and then it's increasing. So this is kind of hard to tell if you're just looking at intervals of 1. So I'm going to look and see if I have a y-intercept of -1 in any of these tables. That would be a clue that it might match number 2. Well, the y-intercept has an x coordinate of 0, so it's not part A. That's a y-intercept of 4. Here's a y-intercept of 0. Here's a y-intercept of 3. Here's a y-intercept of -1. So maybe it's this one. Let's try it out. If the slope is 3, that means if I decrease, so this is going from 0 to -10, decrease by 10, then this should decrease by 30, which it does. Now another way to do this, if you have a graphing calculator at home, is you could enter 3x minus 1 in your calculator and then look at the table. Now I realize not everyone has this at home, but you do have Desmos. You could use Desmos to do this. And I can't switch from my paper and pencil to the computer screen, otherwise I do a quick demonstration. But if you've got a graphing calculator at home, this is a great way to check and see if the table matches. Now it doesn't, you'd have to go back and look at what the value for -10 is, and you'd have to look at each of those values and make sure that it's right. But I just want to show you that technology should support your learning. It shouldn't replace it, and let's use it when we can, especially when you're taking SAT and you want to save some time. I want you to know how to use that tool and use it well. So if I were to substitute, maybe let's take a positive number 2, x value of 2. 3 times 2 is 6, 6 minus 1 is 5. So I'm pretty sure D matches with 2. Let's look at number 3. Number 3 is exponential. It's got an x in the exponent. So let's take our friend 0 and substitute 0 for x. If I were to substitute 0 for x here, that would be 2 to the 0 power. I'm going to write on my paper and show you. For y equals 4 times 2 to the x, if I do f of 0, it would be 4 times 2 to the 0. Do you remember what anything raised to the 0 power is? 1. It's actually 4 times 1, which is 4. So that means we're going to have a y-intercept of 4. So let's see if we have a y-intercept of 4 on C. No. B. No. A. Yes. Okay, let's take one more value. If I substitute 1 in the place of x, that would be 4 times 2 to the first power. 2 to the first power is 2, so that would be 4 times 2, which is 8. So I think A matches with 3. And if you just look at this, look at how much this is increasing. Let's see. Well, they've got these written so that they're decreasing. Okay. Well, if you look at that jump from 8 to 4, of course this is going down by 4. Okay, I don't want to get too sidetracked. So A is 3. Part C, or let's see, part number 4, y equals x squared. That is, if I substitute 0 for x, I get 0. 0 squared is 0. So I think it's going to be B. Let me check and see. If I substitute 1 for x, 1 squared is 1. Oh, that doesn't match. This would be a 1 if this were y equals x squared. Now I'm looking at the one right underneath it. It's got negative x squared. I think that's going to match it, because if I substitute 1 for x, I get 1 squared. Take the opposite of that, I get negative 1. If I substitute 3 for x, y equals negative 3 squared, 3, and I'm just going to take a second and show you this because this is a common misconception. Y equals negative and then 3 squared is not the same as negative 3 in parentheses squared. This would be negative 3 times negative 3. This is going to, order of operations tells me to do exponents first. So I'm going to do 3 squared, which is 9, and take the opposite. So this is positive 9, this is negative 9. So I think that 5 is going to match with B. For C, or for number 6, x squared plus 3, if I substitute 0 for x, I get 0 squared plus 3, so that's 0 plus 3, which is 3, so that matches. Let's just try one more value. 2 squared would be 4, 4 plus 3 is 7, so I think C matches with 6. Not too much work to show on that one, and that's okay. For 153, pause, draw the diagrams, come back to it. It says without referring to your polygon graphic organizer. See if you can recall the names of the shapes below. How did you do? Check your answer. So kind of try them as we go along. This has 2 sides congruent. This is an isosceles triangle. Here we have 5 sides. All 5 sides are equal. So this is a regular, also all angles are equal. So this is a regular pentagon. Here we have both 2 sets of opposite sides that are parallel. So this would be a parallelogram. Here we have 3 sides, all different lengths. We also have one angle that is greater than 90 degrees, so this would be an obtuse scalene triangle. Let's see, E, oh, I forgot to put the right angle in there. We have 2 sides that are equal, and we have a right angle, so it's an isosceles right triangle. F, we have 2 sides that are parallel. Remember, the arrows are for parallel. Those 2 sides are not equal. Parallel is not the same as equal. So this is a trapezoid. How did you do? Did you remember all of them? All right, 154. Read the math notes in this lesson and then answer the following questions. The cost, well, let's read the math notes. Okay, so you are expected at this point to be proficient with exponential models, with exponential equations. If you're not, if you're shaky on any of this, let's work together and help you get up to speed, whether that's videos or one-on-one help or extra posters or whatever. Maybe it's some Khan Academy lessons. Let's make sure that you feel confident with exponentials. I will do some explaining as we do them, but as the year goes on, I won't explain as much because I will have expected you to have done the homework and watched the video and so on. Okay, situations that grow by equal factors, multipliers, over equal intervals can often be modeled by exponential equations. An exponential function is a function of the form f of x equals ab to the x. And in this case, b is going to be positive. B is greater than 0. B is not going to be 1, and this beginning value will never be 0. So note that the variable x is the exponent. All exponential functions of this form have the x-axis as an asymptote because f of x does not equal 0. Do you remember what asymptote means? You may have just touched on it last year. It means that this graph is going to come very, 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 very close to the x-axis, but it's never going to cross it. Since b to the 0 equals 1, if I plug in 0 for an exponent, then that's going to give me 1. That would leave me with a. A is the value of the function when x is 0. A is your y-intercept. The base b is your multiplier. So that's what it's increasing by or decreasing by. So for example, if y equals 3 times 2 to the x, a is 3, b is 2. So therefore, in the table and graph it right, 0, 3, there's your y-intercept. And for each additional unit of the x value, the previous y value is multiplied by 2. Your multiplier is 2. That means last divided by first. That's kind of how we did it a couple of years ago, is you take your last value divided by your previous value. That gives you your multiplier. You're multiplying by 2 to get the next y value. Okay, to write an equation for an exponential function of the form y equals ab to the x that passes through two given points, create a system of equations by substituting one point into this equation and then substituting the other point. Rewrite both equations in a equals form, solve the system to determine the values of a and b, and then write the equation. So this is one way of solving for a if you don't know it. So for example, if you had the points 2, for example, suppose the value of a rare stamp has increased exponentially. It was worth $14 2 years after Sean purchased it. 5 years after, it was worth $112. How can you model the value of the stamp over time? So 2 years after he purchased it, it was worth 14. 5 years after he purchased it, it was worth 112. So there's your 2 points. So you would plug in 2 for x, 14 for y. Then you would plug in 112, or 5 for x, 112 for y. Then you would isolate a. You would get a by itself by dividing both sides by b squared. So that would give you a equals 14 over b squared. Here it would give you 112 over b to the 5th. So if you were solving for, whoops, I got my water. If you were solving for b, you would have 14 over b squared equals 112 over b to the 5th, because if a equals this and a equals this, then these two expressions must be equal to each other. So that's a proportion. If I cross multiply, I get 14b to the 5th equals 112b to the 2nd, which would give me, I would divide both sides by b squared. And by the way, this is kind of complicated, so hopefully you are following along with me. If not, it's okay. It's still good to pay attention and try to get it, or try to get pieces of it, but it's okay if it doesn't make perfect sense today. We will come back to this and keep circling back to it. So when I divide b to the 5th by b to the 2nd, that's where this b to the 3rd is coming from. When you divide powers, you subtract the exponents. Now we're going to isolate b. So that's going to mean dividing both sides by 14. That's what they did here. And 112 divided by 14 is 8. So if b to the 3rd is 8, b must be 2, because 2 times 2 times 2 is 8. So that gives you b. So you plug in 2 for b, and then you just solve for a. So they're just taking this point, substituting 14 for y, 2 for b, and then 2 for x. 2 squared is 4, dividing by 4 on both sides, and then solving for a. That was a lot. I'm not going to do all of that on the next problem, but it's good for you to see that. For 154, we have that the cost of a large flat screen TV is decreasing 20% per year. Okay, so if it is decreasing, then the multiplier is going to be between B is going to be between 0 and 1. So when I'm trying to figure out what B is, I know if it's decreasing, I know this should be smaller than 1 and bigger than 0. Well, if it's decreasing by 20%, per year, that means that it's still retaining 80% of its value. And that's going to be my multiplier, 80%. 80% is 80 out of 100, which would be 0.80 as a decimal. Now that's one way to think of it. That's kind of how I think of it. If it's decreasing by a certain percentage, it's retaining another portion of its value. You could also just say if it's decreasing, you know it's going to be 1 minus whatever this percentage is. So 1 minus 20%, 1 minus 0.20 would also give you 0.8. So then B is 0.8. Okay. Part B, if a 50-inch flat screen costs $1,200, what will it cost in 3 years? Okay, so the cost of a large flat screen is decreasing 20% per year. So they're giving us, this is my original cost. This is what I'm starting with, $1,200. I want to know what it's going to be in 3 years. So let's substitute $1,200 for the starting value. So y equals 1,200 times 0.8, and we're talking about 3 years, so to the third power. And then I'm just going to use my calculator, quickly figure that out. $614 and 40 cents. Okay, so that's part B. Part C, using the same rate, what did it cost 2 years ago? Well, okay, I'm going to use that same equation, but instead of putting a 3, I'm going to put -2 for 2 years ago. So 2 years ago, it was worth $1,875. Okay, part D. Write the equation of a function to model this situation. Well, we kind of already did that. This equation would be y equals 1,200 times 0.8 to the x. X is your time in years, and then y is the value in dollars. As the time goes by, it's decreasing 20% per year. So that gives you a sense of what a 20% decrease would mean. It goes from 1875 down to 1,200 in just 2 years. Okay, for 155, it says simplify this expression by combining like terms. So a term, this is important for you to know, a term is a single number, variable, or product of numbers and variables. how many terms are in the original expression, how many in the simplified expression. So if we look at this expression, there's 1, 2, 3, 4, 5, 6. Those are, each of those is a term. So there's 6 terms when we start. And let's go ahead and simplify. We've got we've got here 5x squared and 4x squared. Those are like terms, so we can combine those and get 9x squared. Positive 6x, negative 8x, let's combine those. That's going to be negative 2x. And then we've got negative 3 and positive 2. If I combine those, that's negative 1. So we started with 6 terms, now we have 3 terms. Part B says when variables are multiplied by a number, the number is called a coefficient. What is the coefficient of x in your simplified expression? There are posters, I think, in the room, I'm pretty sure they're up, with these words. So it is important for you to know these words. The coefficient of x, so the number that's being multiplied by x, is negative 2. And that's it.